In this lecture, we will see about introduction to normal incidence. So just I will introduce the terminology related to this normal incidence. So for example, I will take the interface which is separating the two media is like this. You assume this is the boundary. This is the boundary separating the two media. It can be interface. So, and it is a plane actually, which is separating the two media or surface. So we will consider it is a medium 1, it is a medium 2. Medium 1 having the permittivity is epsilon 1, permeability is mu 1, conductivity is a sigma 1. Similarly, you can take the permittivity of the medium 2 is epsilon 2, permeability is mu 2, conductivity is epsilon 2. So that the characteristic impedance is given by eta 1, which is a function of these three, and here the characteristic impedance is eta 2, and it is a function of these three. Now in this way we have defined the two different media with their constitutive parameters, permittivity, permeability and conductivity. Because this is representing the boundary, we need to deal with here normal with the boundary. That means I am taking the normal to the boundary that is perpendicular to the boundary like this. So this is indicating normal. The terminology here it is including the normal to the boundary. Okay, so in this manner we have taken. Further, again I am taking the diagram. This is the boundary I am taking, and you need to keep one important point in your mind, that is boundary is the plane, not a line. And as I said, it is a medium 1, it is medium 2, and I am going to deal with the normal to the boundary like this. This is a normal. And just I will think that this boundary is nothing but xy plane, and this is x direction, this is y direction, y axis is coming out of the screen. Okay, then the normal should be perpendicular to xy plane, that means the z axis. So z axis is the normal, and boundary is nothing but xy plane. Like that I have taken the interface which is separating the two media. That means medium 1 is available for z is less than 0, medium 2 is available for z is greater than 0, like that we can tell. And these two media are separated by the xy plane. Okay, now I am taking one incident electromagnetic wave. That means the electromagnetic wave which is incidenting like this. How did I take this one? This is an incident electromagnetic wave, that one you have to understand. Okay, and which is making an angle of theta I with the normal to the boundary. Here the main point is the wave is making the angle, whether it is with the boundary or with the normal to the boundary, you have to be careful. Okay, I am making the angle theta I with the normal to the boundary, not with the boundary. With the boundary means you have to take this one, because this is the boundary. You have to take with the boundary means this is the angle. But I am defining the theta I, which is the angle made by the incident electromagnetic wave with the normal to the boundary, not with the boundary. So that is the definition of the theta I. And because of the impedance mismatching between the two media, we have taken eta 1 is the impedance related to medium 1 and eta 2 is the impedance related to medium 2. When the wave is striking on the interface which is separating the two media, it is seeing the different impedance eta 1. When the wave is traveling in the medium 1, it is seeing the impedance is eta 1. But whenever it is entering into the medium 2, it is seeing the impedance is eta 2. Eta 1 is completely different from the eta 2. So when the wave is seeing the different impedance, certain intensity of that particular wave will be reflected into the original medium like this. So this is the reflected wave. But remaining will be transmitted into the medium 2. That is this one. Okay. So here we have to make the angles related to reflected wave and the incident wave. So the reflected wave is making the angle of theta r. That means the angle of reflection, because that is a reflected wave. I am taking theta r with the normal to the boundary. Similarly, the transmitted wave is making the angle of theta t with the normal to the boundary. You have to keep one thing, that is all these three signals. Now we have the three signals. One is incident electromagnetic wave, second one is reflected electromagnetic wave, and third one is the transmitted electromagnetic wave. These are making the angles of theta I, theta r and theta t with the normal. With the normal to the boundary. Okay, not with the boundary. That is the main point you have to understand. And one more thing you have to understand here, whatever the amount of angle I have taken for theta I, which is same as the angle of reflection also, that is theta r. But if you see the diagram carefully, I have made theta t is different from the theta I. That means it is not going, for example, this is the boundary and it is normal to the boundary. If this is the incident wave, the transmitted wave should not be like this. That means it is making the same angle with the boundary. That means here whatever the angle is there, it is very much different with this one. That's why if you draw like this, it is wrong. We have to make the difference in the angle. That means it can go like this, or it can go like this, it can go like this. So this theta t should be different from the theta I. Like that only you have to draw the diagram. Okay, so here clearly you can see this transmitted electromagnetic wave is making different angle, that is theta t compared to theta I or theta r. So we have to show that one in the diagram. Okay, so wave is bending and entering into the medium 2. That property we have to show in the diagram also. So we'll see the remaining things in the next class.